Good afternoon. I hope you guys got a chance to go through the exhibition area. I'm sorry that I'm starting a couple minutes late. We'll try and get this going. Next up, we have Miguel Farah. Is that the right way to pronounce it? Close enough. Okay. Talking about video analysis with AI, and I'll just turn it right over to you.
Awesome. Thank you.
Thank you.
And thanks for having me. Thank you. All right. So basically, I've been in analyzing video with AI for I would say 15 years. And I want to focus on how I went from convolutional neural nets to the new LLMs. Actually, it's a step that I did recently when I joined the Hugging Face. And by the way, who knows Hugging Face here? Can you raise your hand? Okay, almost everybody. That's very good. Then I can go very quick over that. So yeah, Hugging Face is like GitHub, but for the machine learning AI world. You have data sets, you have models, and on top of that, and maybe it's less known, we maintain a lot of key libraries. For example, the Transformers library is something that our team maintains. Is used by a lot of people, big companies, the small ones. We have a lot of partners, so we are well established. Within Hugging Face, we have a small science team, and I'm part of that. And basically, we look at the open source community in machine learning AI, and we try to tackle problems that we find important and that nobody is tackling. And sometimes this means creating data sets, sometimes it's training models in areas that nobody's doing or that require an amount of GPUs that academia doesn't have, for example. And here I just picked a couple of examples. One is we all know that if you ask ChatGPT to do some additions, the results sometimes are not accurate. So we wanted to prove that LLMs can win math Olympiads, and we actually did it a few months ago. And we not only did it, but we published the models, the data sets, and all the reasoning behind the architecture that we chose. One example. And another one is recently Meta released Llama 3.2. And the same day our team prepared our library so that everybody can take Llama 3.2 and fine-tune it with your own data set. So that's our commitment with the community. But we are here to talk video. And actually, the first time I worked in video was 15 years ago with my friend Jonathan at university. That's from our pitch deck. We were not very good at choosing photos, but we already saw that there was a lot of content, and there were not really many tools to, browse it and understand it. So we looked at standards. They come from Europe. MPEG was a bit closer to us. So we looked at MPEG 7 and handcrafted features. So for example, we were taking full videos, extracting some frames, calculating simple features like color histograms or how is the texture in this area of the image versus this other one, and so on. And then we were applying basic clusterings and very basic models, logistic regressions or support vector machines. And this actually worked pretty well. Maybe here you can see an example. That's prior all the web-based applications. I think this was done in Visual Basic, this small front end. And you could just push a clip from a show, and it was returning similar clips. And the trick behind the scenes is that almost all those shows had the same background, were consistent in terms of background, so it was working very well. Back then, something very important was the development of signal processing filters, because the proxies that we found in broadcasters were very, very low quality, and when we wanted to parse some of the text that came from news agencies, it was very difficult to read with OCR because the compression was affecting the text, and then we could not actually read the characters properly. So we did a lot of filters like that. But that quickly changed. I think 2012, we have AlexNet. We have the first person that runs convolutional neural nets in GPUs. And this changed the paradigm, and very, very quickly. In 2014, I was part of Disney, and we started putting this in production, which means that just in 2 years, we go from an academic prototype to having libraries like TensorFlow, Keras, Torch, and later PyTorch. that we could leverage. And at Disney, for example, we were using it to annotate characters, locations, and a bit later activities, and even animated characters back then. CNNs work pretty well. I moved from Disney to YouTube, and I was still using CNNs to annotate all the content that users upload, but also the content that advertisers upload. A bit later, I decided to leave media, create a startup in agritech, and I was doing this real time. I was finding fruits, obstacles, and pass this to our robot so that it could do some of this automatically. Again, CNN. So why would I change? That worked super well. I was happy with it. And I had a recipe in my head already. So this is what's called an active learning loop. And the idea is you have some people that help you annotate the data set or yourself. Then you train a model, you label content with this model, and then you have somebody reviewing this. Usually the reviewers are very senior persons in your team that take care of saying this is correct, this is incorrect, or no, actually this is a new class that you didn't know before. For example, if you are annotating a TV series and you have a new character in season 2, you want to make sure that this is something that the reviewer adds. This type of loop, I used it for since I was at Disney until my last prototypes. And most of the magic happens in how you decide what you send to the reviewer, because they are very senior people, so you don't want to send them a lot of work. You want to keep them there doing their job. So there is a lot of literature and a lot of work to decide what you send and what not, and assess the risk of making mistakes. If we look at from a technical perspective, what were we doing here when we were training the models? Most of the times I was never training a model from scratch. I was taking a model trained with academic datasets like ImageNet, and I was doing what's called transfer learning. The idea is ImageNet, in this case, it has 1,000 outputs, 1,000 categories that are a bit useless for the media world. Maybe you have 50 types of mushrooms, 20 types of cars, so not really very interesting. But the weights in the different layers that got trained have knowledge that we can rescue and reuse for our use case. And that's what we were doing. Rescuing those weights and then creating a new fully connected layer at the end with the outputs that correspond to our case. In this case, I have a beach mountain data set, so only 2 outputs. But so this is what I rinse and repeat for long. And in the last 4 months, I entered into large language models when I joined Hugging Face. And I was quite lucky because Hugging Face is a remote company, so we are all world distributed. But luckily, in the city where I live, this is Bern in Switzerland, I had those folks also working for Hugging Face. And actually, those are the authors of this book, so they know pretty well what they talk about, and this allowed me to ramp up very quickly. Comparing how I was training CNNs with the training of LLMs, I mean, it's crazy, the resources and the complexity. Complexity in terms of recipe to do the training. Here, I did 3 blocks in the recipe, but in the last models, like Llama 3.1, you can see that there are even 5 steps or maybe even more in between those. Very quickly, basically in pre-training, the data is very raw. It could be, for example, a copy is raw, but a lot of data. It could be a dump of full internet to train the model. And the goal is just to predict the next token in text. You need a lot of GPU resources, so it's only a few people that can actually do that. Then in the supervised fine-tuning is where we convert the model into a chatbot. So we provide questions and answers, and the model starts to behave that way. Here at Hugging Face, we released a few libraries that allow you to, a bit copying what we do in compression with video. It allows you to quantize the model and train these with way less resources, to the point that some LLMs, you can train them with a single GPU. A powerful one, but a single GPU. And the last step is the human preference training. And this is, maybe you have seen this if you use ChatGPT, that sometimes in the answer you have actually 2 answers and it tells you which one is better. This is part of the human preference training to figure out what we prefer as users. For company models, this will be more about, is this aligning with the behavior we expect from the model? And you do corrections that way. And this is only for text. Then what happens when we want to add video? The first problem with video is that if it's already very difficult to train a text LLM, when we add video, you even need more capacity. So most of the companies or institutions that train those models, what they do is divide and conquer. They train the text LLM, and then they train the vision encoder separately. Or sometimes they don't even train the vision encoder. They take one that is already trained, and they only have a common pre-training stage where what you see in the image and what you have in the text is the same thing. Like you input the word bicycle, you show a photo of a bicycle, and then this is linked to a common token inside. But rarely you train both things at the same time, only this in between connection. This is an area still that requires a lot of creativity to figure out how you input a lot of frames to the model. This is the approach that Alibaba is using with Qwen2. This is the approach of Meta. The core difference is that Meta is trying to take a few frames at the same time and then compress the knowledge into less frames, for example, go from 32 to 2, and then pass those into the large language model. So have an in-between step for video. There are a lot of things happening in this space. So this is part of the Hugging Face website. We have leaderboards where you can see every week new models appearing, and you can see which ones perform best according to the standard benchmarks that are being used. But to be honest, I mean, benchmarks is okay. It gives you an initial idea of what works and what not, but the best is to try the models. And there is this website that is called Chatbot Arena, and you can compare side by side the models. In the drop-down, you select which ones you want to try, and you see the results. And in my opinion, this is what will tell you which one works and which one not. Imagine you find one that you like, and you want to experiment with it. Then I would also recommend you this website, this Artificial Analysis AI, because you can see different API providers, the cost of running inference with those models, and try it in your infrastructure. If you have GPUs, you can also run it self-hosted. We have TGI and we have DLM, two libraries. It's basically Docker containers that you can run locally and get an API out of the model. But let's go back to video now that we know a little bit about LLMs. So I spent many years just using CNNs, and for me it was still difficult to understand what are LLMs bringing to the game, because at the end, we are saying that we have an LLM that we train separately from the visual part. Then we create a weak connection. What is this actually bringing? Is it worth all this computational resource for video or not really? And the answer is yes, it is actually very useful. And I just picked a couple of examples. Last month, for example, I did a data set called Find Video, with 500,000. It started with 500,000 videos that are Creative Commons, and I wanted to classify them using a taxonomy. And for this, I used an LLM that the input was the closed captioning of the video, the taxonomy, and some frames from the video. And actually did a pretty good job. I just took some samples, I did some human QA, and the result was outstanding. Doing this with a CNN, it would have been way more difficult, and we would have lost all the textual part. So definitely in this type of scenarios, I think it plays a big role. And another one is, I was helping a friend in the automotive industry, where they annotate pedestrians, and from videos that are taken from Teslas or cars that are running in the street with autonomous systems. And this is a common problem they have. That you see posters or you see things that look like persons, but actually is not a person. And to modify this in a CNN scenario, we will need to create negative cases to show to the model, hey, this might look like a person, but it's not. Look at the additional context. In the case of an LLM, it's just a matter of changing the prompt, and just by adapting the prompt, we get the results corrected. So it's way quicker to iterate. Now, if we look at how we were creating data, and I think connecting to your asset management systems, this is how we were doing this when I was at Disney, where we had some models, but at the end we had this iterative process of training the models, review the results, and rinse and repeat. Given what the LLMs can do today, can we do better than that? Can we leverage those LLMs while reducing the well-known hallucinations, but still populate our asset management systems? And the answer is yes. I think we can do that. And this is actually a proposal. It's a prototype that we are doing. And if we are here today as Hugging Face is to, hey, do you guys want to collaborate? Do you want to do this with us? That's our proposal. The idea is you have in your system, you have video, text, and images related with a specific Creative Commons. You can use an LLM to label this with a specific prompt. This is an example. Here I'm asking, can you give me the character of a scene? This will return you something like a chat. And then you can leverage another piece of technology, for example, Instructor or Outlines, that takes unstructured text and converts it into a JSON that we can directly consume. Here, something important to notice is that some of the LLMs, for example, if you use Gemini, you can directly get JSONs out of it, but the quality of the results is way lower when you directly ask for JSON results. It's as if the model is constraining itself in the type of answer that it can provide. So by doing it in 2 steps, we don't lose as much data. Now imagine doing this with multiple LLMs, not only one, or even reusing that you have in your system already. Once you have all this data, we can again use an LLM to decide how we combine this information, and then we involve a person again. But in this case, we only ask to rate the quality of the results. And by looking at the rating of thousands of examples, we can trace back which LLMs we should replace or how we can adapt the prompts. So yeah, this is something that we are putting together with Distillable. Distillable is a library from Hugging Face, and we are prototyping it as we speak. So if you're interested in exploring it, ping me. That's my email, and I will be in town for the rest of the week. Thank you.
Do you want to take some questions? Okay. Anybody have any questions? Steven.
Are you doing anything with facial recognition and audience sentiment? That's something that Disney, Swiss Research has done. They did 300 movies and captured people's faces and were able to document up to 16 different emotions.
So I was a bit involved in this project back at Disney because so that was a split, long story, but this was a split between Seattle and Zurich. And I was a bit involved on that in the mood aspect of it. Now I'm not doing anything on that, but I was very curious in this data set that I created recently, Fine Video. I was very curious to see how good are LLMs at capturing the mood, because it's such a difficult problem. The thing is, Gemini, for example, is doing an excellent job, and I think we have also another 12 labs over there that I think they also have something on that. But the fact that we can, for example, capture the music plays a huge role. Of course, all the facial aspect as well, but when we use multiple modes, it's as if the problem, we are getting better solutions than when we were only looking at the face. Yeah. So I think it's advancing in this sense.
This is not the face in the movie. This is the audience watching.
Yes. We released also a paper on that okay, you know it very well. Then maybe you know the one where we compare the emotions of the people watching the movie with the expressions of the actors, and we see a mirroring, with an exception in comic scenes where something bad happened and the audience is a mirror, an opposite. Yeah, I can provide you the link of the second one. Very good.
Any other questions? Perfect. Thank you very much.
Thank you.